Okay, so I get the fun part of being the teacher, inviting you guys into the classroom. And I think actually this is outside of the professionals sitting at the table, we have the most important job. And Oscar touched on a few issues or points that are very, very important for the classroom teacher when you guys enter the room. And that is to collaborate, 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 collaborate. There must be a strong level of collaboration between the teacher and the scientist. It won't fly well without the collaboration piece. There's got to be effective communication between the two people. And what that looks like, for example, in my room, Dr. Elkis, and I've been in this thing, as John said, for a long time. I had a statistician, I've had an environmentalist, I've had earth scientists, physicists. I've had them all because I have a master's in science. Some things I could remember, some things I was like, oh, holy crap, I don't remember this. So what I did was send me your lesson before you bring it to my kids. And so what I've done is sort of not dummied it down, but I wanted to make sure that they would understand the principles and the vocabulary before the scientists came into my room, so that when they began to speak, I don't want the scientists to dummy it down, because that's not real world experiences. And it's not fair to the children. So it's really critically important that the teacher and the scientists work together. We have the pedagogical experience and wherewithal. You guys have the other experiential pieces. So getting that done, communicate with the scientists prior to the visit. Engagement. I can't say time and time again, or more so, how effective it is to do the hands-on science, because I can read it and we can script it out of the book and I can say, oh yeah, let's turn to page 234. But it has no relevance to them. There's no meaning. So when they can actually see it in action, and then, as you said, amp it up. Then you say, hey, this is what you guys just did. These are the principles. This is the why. Because as scientists and mathematicians, physicists, chemists, the question always becomes, why did this happen? So as the teacher, I interject, and sometimes I go, okay, maybe I should just shut my mouth. But that's the collaboration piece, because I'm saying, wait, push pause. You guys, do you understand what was just said? So that's the camaraderie that you're building. And then you would be amazed that the kids, they're sponges. They just absorb everything. And they're ready to, hey, Mom. I mean, because I've gotten emails. Miss Leonard, I don't know what the heck you've done. Pardon my language. I don't know what the heck you've done in that classroom, but my kid is wanting to do X, Y, and Z.
Mama. Let him talk like
that. But that is so critical. And Oscar, I mean, you took my whole presentation.
I apologize.
When you align what you're doing, and this is, again, the camaraderie piece with the standards, it has to be standards-based. There has to be some alignment. I mean, you can't...
Well, no, I just want to say that a lot of the time we take the science time or whatever math time away from the students, away from the teachers. You know, they only have so many hours in a day. So if they dedicate what would have been the science block to having Oscar come to class, then I want to make sure that it's not, you know, something completely irrelevant. It's not just fun. I mean, I'm going to keep them laughing, I'm going to keep them entertained and engaged, but it's going to be productive. It's not just going to be like, okay, you were studying biology for the last 3 months, and you're taking an exam on it next week. Now we're going to go talk about nuclear physics, and totally take you way off base, and totally give you a bunch of irrelevant information to you right now. And I'll make it entertaining, I'll make it worth your while, but it won't necessarily have that return on investment.
Absolutely. So aligning it with the standards, and because society has now deemed this educational field, we're so test-driven. I will digress. But it's just the nature of the beast, you know. So I will sit with the scientist and I'll go, okay, I'll receive the PowerPoint. And for that entire week before the date that the scientist comes in, I've already hammered the concepts. I've already gone over the vocabulary. So they pretty much are robust in the knowledge base. Not everything, because I want to leave something to the presenter, you know.
Don't steal all our class.
Absolutely.
So I have a question, Mr. Leonard.
Yes, sir.
So how much time in advance would you need the presentation?
Well, you know, I usually do, and I think Dr. Elkis and I, we would do 1 week. So she would, before she left my classroom, she'd say, Mr. Leonard, next week I'm thinking about. And I'd go, okay, just send me your information.
Okay.
And that's all that I needed.
Okay.
You know?
And I don't always, I mean, it's not always a week. I mean, now I pretty much got them down, but the earlier the better, up to a week. But I try to do it at least 2 or 3 days so that there is the ability
To adapt, yeah.
to have Mr. Leonard look at it and start talking to his kids. But now that I've heard this, now I'll work. I'm making it a full week.
No, and I think it's also another critical point is making sure that what's being discussed and what happens in the classroom is very age and grade specific and appropriate. Because it would make no sense to talk about chemical nuclear reactors and you're talking to a bunch of third graders. That just wouldn't make sense. I mean, it could happen.
How do we encourage the teachers to be more proactive?
Well, this is when you can I do this to myself?
Absolutely.
This is when you have a person in the building that will bridge the rest of the teachers together, and they say, and you say, this is what needs to happen. Here are the volunteers that you have. What's your interest? Okay. What science standards must you cover? And then you take it from there. And that's how you sort of team up with and partner with the scientists. So it's actually very pivotal to do this at the beginning of the school year or whenever you guys decide to come into the schools. And then finally, making it real world, because we can have the scientific knowledge and all of the vocabulary, but if it has no relevance to them, then this is nil and void, or null and void. So it has to have some impact with how will this affect them 10 years from now, 5 years from now, you know. So I thank you guys for spending the time and coming. And I'll take questions. Any other questions? Throw them at me. Yes, sir.
I find I'm second year reset volunteer, and the challenge I have is not engaging students and and have fun with them and learning about science, but to use the scientific process. In other words, when I say they want an experiment, well, they have to come up with a guess. So for third graders we call it guess, okay, hypothesis or whatever. But there is a process I need to walk them through before they have fun, before we do that. So being only a second year guy, I'd be interested to know how you all attack that or address that need to apply the science process.
And that's a great question because at least in third grade, that's when they actually participate in the science fair process or project or whatever it is. Something as simple as problem solving. Just that simple. Because you have to have a problem. You ask the questions. You experiment to find out the why. And then you test what you think should happen. And then you reevaluate it. Just plain and simple.
So a problem statement, we call it a problem statement
Absolutely.
approach.
Yeah.
Our third graders, we just, the teachers I work with use, it was very useful. A guess, everybody guess what might happen if we turn on the flashlight and view this object this way. So
I think, prior to just jumping into the entire science experience, then begin with the scientific method. that would be a great start.
I have a quick question. If you don't have a teacher, and I'm not saying I've experienced this at all, but if you don't have someone who, like you said, collaborates well, is able to take the ball and run with it when you leave the classroom and keep the momentum going, and so that next time you come back, you know, the ideas are ingrained and you've got some more runway to work with and not necessarily have to start from point A every time. How do you encourage that by getting with the school's administration or getting with the school? Don't answer now.
Can I ask a question?